We define the basic step function u sub c of t as 0 for t less than c and 1 for t greater than or equal to c. To reverse the step function so that it steps down and is 1 for t less than c and 0 for t greater than or equal to c, how should we change u of c? The way that we can do this is to use 1 minus u sub c of t. Because u sub c of t is 0 for t less than c, so 1 minus u sub c is 1 minus 0 is 1. And after c, u sub c is 1, so 1 minus u sub c is 0 for t bigger than or equal to c. We may also have a function that steps up and then back down. For example, it could look like 0 for t less than c, step up to 1 for t between c and d, and back down to 0 for t bigger than d. How can we build a function like this out of our step function? Well, we can use u sub c minus u sub d. In the beginning, before c, both u sub c and u sub d are 0. So uc minus ud is 0 minus 0 is just 0. Between c and d, uc is 1 while ud is 0. So uc minus ud is 1 minus 0 is 1. And finally, on the right-hand tail, uc and ud are both 1. So uc minus ud is 1 minus 1 is 0. As you can see from these two examples, we can start building more and more discontinuous functions by using the step function as a basic building block. And if we want to scale up our step, so it jumps up to 2 instead of just 1, then we can take 2 times u sub c of t, or whatever we want our step function to step up to. We can also take various combinations of these modifications. What if we want to have a function that steps up to 2, but then back down to 1? That is a function that's 0 for t less than c, 2 for t between c and d, and back down to 1 for t bigger than d. Can we build this out of our step functions? Yes. The way we do it is take 2 times uc minus ud. For t less than c, uc and ud will both be 0, so 2uc minus ud is 0 minus 0 is just 0 as we wanted. For t between c and d, uc is 1 and ud is 0, so 2uc minus ud is 2 minus 0 is 2. And finally, for t bigger than d, uc is 1 and ud is 1. So we have 2 times 1 minus 1, which gives us 1 for values of t bigger than d as we wanted. So as you can see from these examples, we can use these step functions as basic building blocks to build other discontinuous functions. So our understanding of these step functions and their Laplace transforms will be key to understanding how to solve differential equations with discontinuous functions.